Hey guys, it's Miss Wesley again. Today we're going to work on a little bit of practice with solving rational equations. So a little bit of extra practice on 8-6. And again, we've got a lot of problems here. We're going to work through just a couple of them together so that you have some to practice on your own. And my goal is to get even better at not covering my writing with my hand. I am the worst at that. So I'm glad you guys can pause this video. Let's start with number 4. I'm just looking around the top of this, and I love to point out opportunities to be able to use alternate methods to be able to solve some of these rational equations. And we have a method where we multiply everything on both sides through by the least common denominator. But if you see something here where you've got two terms that can easily combine, like the 10 and the 4, and then both of these fractions that are both over x, I say take that opportunity. Let's move the 4 over to this side. We're going to actually subtract a 4 over to the left-hand side to get a 6 on that side, subtracting 4 from both sides. Then let's add 13 over x to both sides of the equation as well. That way we get this over to the right-hand side. So 6 is going to equal 5 over x that was already there plus another 13 over x. And these were two easy fractions to combine. They're both over a common denominator. It's just sitting there waiting for you. So you have 6 equals 18 over that common denominator of x. You can probably look at this and tell that x will be 3 or multiply both sides by x. Say 6x equals 18 and you get x equals 3. Always look back up to make sure this thing would check if we plugged it back into the original. And it certainly needs to be an answer that doesn't make you have 0 in the denominator. You had your domain restriction there, but this one should check out if plugged back in. Okay, let's move right down to the one underneath of it. This one looks kind of curious. You've got two different denominators there, but actually, why'd I say different? Because it's an x plus 4 and an x plus 4. I don't think we need any fancy tricks here. I say you combine what's just sitting here over the common denominator. You get to add across the top as long as you keep the bottom what it was. So this is x plus 4 over that common denominator. Now, my mind is already wondering about this x plus 4 over x plus 4 because I feel like that could be written as a way easier number. This is plus 2 equaling 0. Some can tell right now that there will be no solution to this problem. And if we did continue to try and solve it out, I bet you would get an extraneous root. This just looks so weird having the same thing over itself. Well, really, if we tried to isolate the fraction now, and we had x plus 4 over x plus 4 and move the 2 over, so you get equals -2, you could multiply both sides by this x plus 4, kind of cross multiply, to have x plus 4 equals -2 times x plus 4. Let's see what this gives us. X plus 4, -2x minus 8. And then I'm solving, and let's scoot that over a little bit, 3x, right? If you add the 2x to the other side, equals -12. And you get an answer that I'm not very comfortable with. I get something that would make 0 in the denominator in the original function and every version thereafter. This is an extraneous root, ER. Right? No real solution, empty set. Now, backtracking. Should I have been able to notice it way back when? Absolutely. You were probably thinking, Miss Wesley, can't this just be 1? And the answer is yes. Something over itself does equal 1. So way back here, 1 plus 2 equaling 0, that is just bogus, and we are not going to allow it. So there is no solution to number 6. If you guys don't mind flipping over, there's a couple good ones on the back. And you'll notice you've got fractions added and subtracted on this side. So a lot of the stuff we learned in section 8.5 is going to come in handy here. You're looking for your fastest, least common denominator, because I love the method on this side where we multiply everything, all 3 fractions, by whatever is going to be the LCD, the least common denominator. And I can hear you guys now, Miss Wesley, you should factor first. If you see a denominator in the original that factors, do that first, because on this page, at least, chances are you might get one or both of those parts. And here, no big surprise, you get x plus 3, right? X minus 1. So you have that common denominator on that side. So we will give each thing the LCD. So I want to multiply everything through by x plus 3 times x minus 1. We talked about this a little bit in class already. Really what's happening is that LCD is going into the numerator of all 3 fractions that are involved in this equation. So everything cancels here. You just get a 12. Here, look at this fraction. The x minus 1s are going to cancel with each other. And you're still left over with the 3 and the x plus 3. Okay, and then lastly, you've got the 2 that's going to be joined by this in the numerator, making the x plus 3's cancel, and all you have left over is a plus 2x minus 1. Just makes the problem so much easier to solve because now we don't have to worry about those denominators anymore. So give this a try. Let's just simplify. So the rest should be quick. 12 equals 3x plus 9 plus 2x minus 2. Am I doing a good job of not covering up my writing? I don't think I am, but I hope you guys forgive me. So 12 equals 5x plus 7. And this should work out nice. 5 equals 5x. And let's see if we like 1 as a solution. X equals 1. Well, I like what we did to get it, but I don't like this answer. And I think you can tell why. If you look back up into the original, it's one of the 2 original domain restrictions. So again, sad story. The only answer we were allowed to get is an answer that is extraneous, that doesn't work. So 3 would have been bad, a negative 3 rather, and then 1 is going to also be extraneous. Okay, we got to watch out for something like 11 or 12. These are going to be good ones to watch out for because this negative sign right here. I think that negative sign gives this one a star as being a tougher problem. Now, the beginning of this, can you go ahead and factor any denominator you see that factors? Let's try that final one, the x squared plus x minus 6. So that could turn into x minus 2, x plus 3. And we got lucky there because we see those 2 parts of that denominator on the other side of the equation. So we can take the entire equation. And I have a little more room on this side, so I'll write it here. X minus 2, x plus 3. We are bringing, once again, that common denominator into both parts, or all parts, I should say, of that equation. So all 3 parts. See what cancels. In the first fraction, x minus 2 should be gone, right? You just have x plus 3. Now, danger, warning, crazy negative sign here. We got to be careful. The x plus 3's will cancel in this fraction, but that negative sign is going to get distributed into these parentheses. You've got 3 times x minus 2. We'll come back to this. And then the 4 is just a 4, right? You've got the denominator canceling. So just watch out for this part. Maybe I'm overreacting. Minus 3x, and then how about plus 6 since it's minus and negative? This is the easiest thing to miss, I think, is that sign switch that you see there. And then we'll just simplify, combine the like terms. Negative 2x plus 9 is 4. Negative 2x should equal negative 5. And x is 2.5 or 5/2. When I get an answer like this and I have a little extra time, I like to plug back into the original everywhere I see x and just check to make sure that it looks good. But I think we can trust 5/2 as a solution. All right, one more. We've got this. Let's try the one right underneath. And actually, if we have time, maybe we could look at both of these, just strategize. Right underneath, this one also gets a star for 2 reasons. This negative sign, and how about this denominator? That's kind of looking like it's written out of order. So I would start the same way I started the others, right? Would you factor this? X minus 4, x plus 3. See, any denominator that factors, you're going to do that. Now, this is what I want to do to this to take care, and we really haven't seen this too much yet. You're going to leave the first fraction how it is, 2 over x plus 3. Take the next fraction, right? It's minus 3 over 4 minus x, but we really would be interested in changing both of the signs here. We want to make this an x minus 4, so it looks exactly like we have on the other side. One way you can do that is to pull out a negative, making this minus into a plus. I'm going to star that. If I change this sign, I'm entitled to change all the signs in this denominator and make this a positive x minus a 4. That's the move. This becomes a plus, and then now you've got what you need in the denominator. And the other side is the same. 2x minus 2, x minus 4, x plus 3. Okay? So now I guess the problem finishes the way the others did, right? Common denominator goes to all 3 parts. See what you can do. Try it. X minus 4, x plus 3 into all fractions that are involved in that equation. And we're going to see what cancels. X plus 3 is canceling. You have 2 times x minus 4. Here you've got x minus 4 is canceling. So it'll be 3 times x plus 3. And then here you've got, I guess, that whole entire denominator canceling with a 2x minus 2. And it's a little bit easier to solve. What do you guys think? Half of these have had a solution and half of them haven't. What's your money on? So this is going to be 2x minus 8 plus 3x plus 9 equals 2x minus 2. Okay. Like terms, you've got 5x on this side plus 1, and then that 2x minus 2. And then we'll subtract 2x from both sides and subtract 1 from both sides. So x equals -1. On your own time, you can check this solution. At least it's not an answer like 4 or -3 that would give you division by 0. And this one does check out. So that looks like a good solution. Before we look at number 14, I'm going to give you guys the secret word for this video. The secret word is going to be purple because my favorite color is purple. So remember that. And then lastly, this is a complex fraction in the form of a rational equation. I want to see what you guys can do with this one. We've got different strategies for combining this side. I think this one looks worse than it is. You could get the bottom together as one fraction and deal with it that way. So maybe method 1 is going to be 1 over, give this an x and an x. And you have x plus 1 over x. You can kind of simplify a little bit on the left side. And then maybe just instead of 1 over this, bring up the bottom and flip it. Make it x over x plus 1 equals 2. It's just a little bit quicker to solve. You can multiply both sides by x plus 1, leaving you with something like that, and then simplify. 2x plus 2. So you'll get, I guess, -x equaling 2, and x is -2. Didn't take too long, wasn't too bad to handle, just kind of like getting the bottom of the fraction together as one first. Your other option, actually there's many options, you could have taken the original and multiplied both sides by this denominator off the bat so that you can get it over to the other side. You'd have 1 equals 2 times 1 plus 1 over x, like that. And then you could distribute. You guys could take it from here. This is just 1 equals 2 plus 2 over x, if that 2 gets distributed into both parts. And you have 2 subtracted to the other side. -1 equals 2 over x. And you still end up with -x equaling 2, or x is -2. That was a lot of good math. Those were a lot of good rational equations that we solved. So pat yourself on the back. I think that math was so nice that it deserves a nice sip. Can you see it in the video? A nice sip of Dr. Pepper. So I'll be enjoying that. You guys enjoy the rest of your day. All right, see you later.